My name is Alec Warda. I am a software application sales engineer over at Materialise. I have been with Materialise for about a year now. September will be my 1 year anniversary. And at Materialise, I've been given the opportunity to check out our own advanced additive manufacturing facility that we have in-house in Plymouth, Michigan, and also learn about our facility that we have over in Leuven, Belgium, which is where our headquarters is. In Belgium, we have somewhere north of 180 3D printers going on at once. So a little bit about Materialise. We were founded in 1990, and basically just right when additive manufacturing was just starting to get rolled. Our CEO, Fried van Kren, noticed a bunch of issues and a bunch of things that are really cumbersome when it comes to additive manufacturing. And one of those things was the software itself. There was no really good way of preparing builds, no real good way of nesting builds. And at that time, additive manufacturing was very, very young and didn't quite have the scope that it has today. So over the years, we have been taking our own experiences and extracting information from users and some of our clients to see the struggles that they have. And that's how we deploy our software and develop our softwares, just to solve the problems that we see happen most frequently. So one of the goals of Materialise, and something that we have, is our scope of handling every single additive manufacturing technology that there is. Some of the more obscure technologies we don't support as rigorously as the ones listed on the screen right here. And the ones that we will be talking about mostly today is laser sintering and DLP. A lot of these technologies shown on the screen have embedded functions inside of our softwares, but we also have a lot of additional modules that really help these specific technologies as well. So the main scope of Materialise in one of our main goals is to be the complete end-to-end workflow of your additive manufacturing process. So it can start off with Materialise 3matic. So after you get your parts designed in your CAD program, you can put it into 3matic. And 3matic isn't necessarily a CAD program, but it is a design optimization software. Where you can just make some pretty powerful edits to a part and things that really pertain to the additive manufacturing space. And if you have heard of Materialise, you probably think of Materialise Magix. This is our most popular software. Our first iteration of Magix was developed in 1994, I believe. Magix 1 came out around then, and currently we're on Magix 27. So yeah, this is our bread and butter software. And then you may have also heard of Materialise eStage. This is an automatic support generation software. We have a good use case for that in SLA processes and laser powder bed fusion for metal processes as well. And what I will also be talking about today is the Materialise build processor. So the build processor is just increased machine communication from software to machine, therefore increasing communication between person and machine. And then on the right-hand side, you see Materialise Streamix, Robot, and Cloud. We also have our most comprehensive version of all of these put together, which is CO-AM. And CO-AM will manage all of your entire 3D printing process. So when you receive your part from your customer, if you're a service bureau, or when you get your part designed, you can quote your part, see where your part is throughout your workflow, manage all of your machines, have everything scheduled, and be able to keep track of your parts as best as possible, just to make sure that everything is accounted for the most part. And on top of that, it is a cloud-based software, and this software can be held on your own private cloud or Materialise's cloud as well. So starting off with 3matic. As I mentioned before, 3matic is a design optimization software. There are modules within 3matic, but today I'm just going to be talking about the base module. The base module of 3matic has the Lattice module and the texturing module. So lattices, what are they used for? I'm sure a lot of you guys are really familiar with lattices and their use cases. I'm sure maybe some of you have deployed lattices yourself for any of these functions up here. So we will just roughly go through them. Regularity of lattice structures provide great controllability. Properties of these porous structures can be fine-tuned to a particular functionality and performance. So over here on the left-hand side, this is what we see the majority of users use lattice structures for within additive manufacturing, and even outside of additive manufacturing, just general use cases. So really great for lightweighting structures. Materialise has a really big hand in the medical field. So things like hip replacements, shoulder replacements, cranial implants, knee implants, things along those lines. Lattice structures come in handy a lot, and I'll talk a little bit about that down the road. There's also vibration control, things involving packaging like shock absorption, everything involving heat, especially heat exchanging, thermal insulation, and acting as a heat sink. It can also aid in increasing buoyancy, aiding in filtration, acoustic absorption, hinges, and support structures to infill in additive manufacturing process. So one thing is that the industry currently uses stochastic or irregular foams in many applications, and the lattice structures, from what we have seen and feedback that we've gotten from our customers, lattices have the ability to replace and outperform these, usually for a cheaper price as well. So one great thing about 3matic is in its latticing capabilities is its varied beam thicknesses. So after you make your lattice structure, you are able to make it irregular, so it's not just a completely straight lattice structure as you see in image D. So you can make these be change in size by using the uniform or user-based, porosity-based, linear gradient, texture and image-based, or my favorite, FEA-based. And the FEA-based is really cool because you can actually import your FEA results into 3matic, and 3matic will take those results and then develop its own lattice structure and its own thicknesses to conform to your results, just to make sure that your lattice structure keeps its structural integrity and doing what the FEA results outputted, basically. Another really cool thing about 3matic is you can design your own unit cells for the lattice structure. And this is a really intuitive method of making your lattice structure, and just allows for greater customization when creating your lattice structure. The way that 3matic will place your lattice structure onto your part is it is a UV-based conformal. So you can put it either on one surface or between two surfaces. An application for the one surface is to add texture to the part that will promote bone growth on an implant. So earlier I talked a little bit about our involvement in the medical field and how we'll use the lattice structure in hip implants so that your bone will actually grow into the non-toxic hip implant, and it will basically become part of your hip, which is crazy to me, but super cool that your body will do that. And you can also put them between two surfaces. And again, as we talked about before, this can be used for lightweighting, adding strength, aiding in heat dissipation, acting as a heat exchanger, etc. So this is a case study that we did with one of our customers. They are in the aerospace field, and how they use the lattice structure is they put the lattice structure inside of their airplane wings. And this did a few things. So it not only made the airplane wing lighter by replacing the solid material with unit cells and channels, but it also helped in the de-icing process by taking the hot air from the engine compressor and dispersing it throughout the wing and aiding in the de-icing process. So the flaps that some of these airplanes will have when de-icing have to work a lot less, therefore working much more efficiently when de-icing itself. And now texturing. So again, very similar to latticing. I'm sure a lot of you guys are really familiar with texturing and maybe the use cases and things like that. But I'll just go over real briefly what some of the cases that we see. So aesthetic textures, you can add some personalization, whether that be for personal or company use. Surface decoration with organic or design patterns. You can also add some organic effect. Again, this can be if you're either in the medical field or if you want to slightly change the, the texture of the part just to make it more useful in your use case. And it can also have a blurred layering effect of the 3D printing. Functional textures. We see a lot of grip, a lot of acoustics, which is really, really interesting to me. That was one of my favorite projects I was able to work on. Reducing reflection, aiding in aerodynamics, so making streamlines or something like that, aiding in cushioning, increasing filtration, and increasing reinforcement of a part. And then texturing on a prototype. This is really interesting as well. Prototyping is a really common thing in the additive manufacturing industry. And that lead time of getting a prototype to the market, or at least getting it, ready to be showcased, can be a really long time. And adding these textures can make it real finished and can give it, sort of that final product look, and will just reduce that prototyping down pretty significantly. So UV parameterization surface mapping, very similar to how the lattice structure works. 3matic will put its texture on a part using the UV parameter set. And as you can see in the image displayed, the image on the right was not using UV parameterization, and all of these curves in the part can be really cumbersome when putting a texture on a part. So on an edge, it can look real stretched out, or maybe on a concave surface, it'll look really squeezed together, or so. And 3matic does a really good job in taking that into account and understanding the geometry that you're working with, just to make sure that it's being eliminated. So as you can see in the middle image, this is a really nice looking part, where everything looks really uniform, even around the curves. Everything stays as consistent as possible. The way that 3matic takes its textures is from bitmaps. So these are some of the common ones that we see. On the left, and the image on the left is it from the top view, and the image on the right is sort of its isometric 3-dimensional view. So some common ones we see are egg crates, ribs, pins, leather, wood, and weaving. Pins and ribs are really common ones that I see also. These are good for acoustic changes. Ribs are really great for structures, and weaving is a common one too. This can give, if you're working with, some people will actually print in carbon fiber, and weaving is really nice for carbon fiber as well. Once you have everything designed and changed in 3matic, then you will put it in Materialise Magics, which is a separate software, and this is solely for data preparation. So getting your parts ready to be printed, supported if they need to be supported, some last minute design changes if you want. These design changes are real remedial, and we'll get into that a little bit. This is the workflow that you'll go through when you have Magics. You'll import the part into Magics, make sure that the part is properly defined, and if it is not defined, then you'll use the various tools in Magics to fix the part, make some basic edits, as I mentioned before, prepare it to be built, export it, and then use the quality control functions as well. And this is something that we've been working really hard on. You can make custom reports just to get everything on black and white sheet of paper. You can export 3D PDF as well, and utilize the measurement functions within Magix to make sure that your final product matches what is displayed inside of Magix. So ever since Magix 26, which was released in May of 2022, and subsequent versions of Magix, you are able to import any type of CAD file there is. So if previously users have to, and I'm sure maybe some of you guys have had to go through this process, if you're using SolidWorks or CATIA or Autodesk Inventor, you'll have to convert the 3D file into an STL file and then import it into Magix. Now you can just import the CATIA part or the OBJ part or the SolidWorks part directly into Magix, and then you will be able to control the part in its native CAD format or its BREP format. Once you have it imported as its CAD format, you can transfer it into an STL file inside of Magix. And Magix is very, very good at interpreting STL files and creating STL files for that matter. And you have full control over creating your STL files. So you can manage the part resolution, determine how you want Magix to interpret the way that the triangles are defined. And then you can save all of these settings as well as profiles and make sure that it's consistent throughout your entirety of using the software. This import function will also retain native color information. So Magix has been really useful in terms of fixing files ever since its release in 1994. And some people just use Magix for the fixing files. And if any of you guys are familiar with additive manufacturing and maybe have had to do this, you can understand just how annoying it is when you get a part and maybe you're missing some triangles, or maybe you have some inverted triangles, or maybe some triangles have just sort of bugged out and are attached to triangles it shouldn't be. And this combines really well with the import functionality of the newest versions of Magix software, because 3D softwares will interpret STL files differently, right? So you'll have SolidWorks interpreting a 3D or an STL file a little bit differently than how Autodesk Inventor interprets an STL file. And when a single STL file goes through all of these different softwares, these files can get all messed up and can not be properly defined. So Magix has a few very powerful tools in terms of fixing a part file. There's an automatic function, a semi-automatic function, and a manual fixing function that will allow you to repair really complex models and really difficult issues that may arise that seemingly could have been, maybe we have to scrap this part or we have to get a completely new model. You can do a lot of fixing just within Magix. And like I said before, a lot of people have Magix just for the file fixing functions. So once you have your part fixed and then you are getting ready to build it and you want to make some slight changes, similar to the 3Matic software, Magix has something called the structures module, and this is also a latticing module. However, it is not quite as robust as 3Matic is. So again, it's a latticing module, so really great for lightweighting a structure while keeping structural integrity. Really good for being used as a heat sink, and it can just increase part quality when using the 3D printing process. Another really useful thing with Magix is there's the prop generation. So the prop generation will aid in temporarily providing supports to a part. So if you see the image on the right, you can see that there's sort of these thin walled areas. And if you're going to 3D print this part, these thin walled areas can sometimes tend to shrink inwards, and you can use the prop generation to hold those parts or those walls where they need to be so that they do not shrink inside. And then also you can see the measurements that you can change with these prop generation tools, and you can make them very easy to break off or make them quite robust. And another really cool thing that you can do is you can combine this prop generation tool with the structures module. So I've seen people actually lattice this prop that has been generated, or this little support structure that has been generated, to aid in even easier part removal or aid in even more material saving. You can also label and mask label parts. So labeling in Magix is very, very simple. As you can see in the image provided, you can just select label function, draw a rectangle where you want the label to be, and then you can type in what you want the label to say. You can make this either embossed or engraved. You can add a drawing to it, use a projection view, maybe if you have a different, if it's not a flat shape, and you can also use a data matrix. And the data matrix is cool because you can not only import your company logo or something using a .dxf file, but you will also be able to map label parts using it. So say that you're printing 100 parts at a time and you like to serialize your parts. You can make an Excel web sheet that will mass label the entire part, or the entire build volume, I should say. And Magix will understand what the pattern is on the Excel web sheet, and it will use the pattern that is shown on there to project it on every single part. Next, we have our Nestor tool. This is another one of our more popular modules within Magix. If any of you guys have used laser sintering, and you understand how annoying it can be to nest these parts. It can sometimes take hours, especially if you're using geometries like what's shown right here. There's a bunch of different things going on. There's a bunch of, shapes, a lot of thin walled parts, a lot of, really skinny parts. And these can be really annoying to orientate and to put inside of a build volume. So the Nestor tool will be able to detect out of bounds, have collision detecting, see interlocking parts, evaluate your wall thickness, see trapped volumes, and do a build risk analysis. And the build risk analysis is an empirical function, so you will need to run the build risk analysis a few times just so Magix can learn about what's going on, and then it will be able to foresee some failures that may happen. Some continuation of the 3D Nestor. These are the settings that you are given when making the 3D Nestor. As you can see at the top, I have geometry selected and not bounding box. You can have the bounding box selected, but I always like having geometry selected because this will give you the most customized and the most dense build possible. And this is very useful for a multitude of reasons. Going from top to bottom and from left to right, you have your part interval in margin to sides. So the part interval is just the distance from part to part, and the margin to sides is the distance, the minimum distance from part to the side of the build volume. You can also select and optimize your nesting density. If you have a target that you guys like to hit, you can put that here, and then the 3D Nestor tool will continuously run until it hits that nesting density. Again, build risk analysis, and you also have freedom of parts. So over here on the right-hand side, you can decide how you want the parts to orientate themselves. So if you select this, there's a big drop down that comes down, and you'll be able to have it be rotated by 15 degrees, translate and move. So you just get the most customized orientation of every part to increase that nesting density. Additionally, with the 3D Nester tool, we have the sub nester and center box. So a lot of things that I have experienced and that I have seen other customers or users experience as well when printing small parts with larger parts is when you're trying to extract the powder, or when you're trying to take the parts off from the cake. Sometimes, if you're vacuuming up the powder, you might inhale some of these smaller parts. And what the sub nester it will group up these small parts and put them into a little subgroup, hence sub nester, and it will place it somewhere inside the build volume. And this is all user defined. And what you can also do with that is you can put a center box around it. And this will protect those small parts and prevent you from losing any of these little tiny parts or accidentally sucking up these tiny parts inside of a vacuum or something like that. And you have complete customization of this center box as well. You can make it into a square, you can make it into a circle, you can define the shape, you can make it into a triangle if you wanted. But you can change the size of the center box as well. Again, if you want to save some material or anything along those lines, while also keeping the function of the center box as well. Another thing that you have is something called slice distribution. And you'll be able to check the slice distribution of your build volume just to make sure that it's as the cross section of the build volume is as consistent as possible. And if you can see the image on the right, this one's pretty good, but it's a little all over the place. But it will give you a good idea of what the slice distribution looks like with respect to the Z height. So ideally, you would like this just to be a straight line. Then you would just have a completely consistent XY cross section throughout the entire build volume. But this is just another tool that you're given to evaluate your build prep and evaluate your build volume to make sure it's as best as it can be. So this is just a little overview of what we talked about. We also have the support generation. So if any of you guys have some experience using laser powder bed fusion systems or using that technology, you know how difficult it can be to add supports to a part and successfully support a part, especially with some of these really rigid materials like titanium or some versions of stainless steel. They can be pretty strong to deal with. We have our SG Plus module, and we also have our E-Stage software. Next, we have our Materialise build processor. So once you have your part fixed, and once you edit it, and then once you build prep it and put it into the build volume and all of that, then you have to actually put it to the printer. And right now, it can be a little difficult getting it to the printer. The common workflow is exporting it to a thumb drive and then walking over your printer and then plugging it in, and then that's how you're going to get it to your printer. It would be really nice if it was the same as just a 2D piece of paper, whereas if you just have something on your Word document and then you just press print, select your printer, and then do the settings that you want to do, and then it gets printed. The build processor does just that. So we have partnered with many different OEMs, and it's basically that exact same interface where you will build it through the build processor. So this is what it looks like. You'll select your machine that you want it to be printed on, select the settings that you want to change, maybe change the profile if it's a different material, or depending on the machine that it's running on, you can change all of these things, and then it will be sent directly to the 3D printer itself, and you won't have to manually put it into a thumb drive and then walk over to the printer and then plug it in and do that entire thing. So this is just another little look at our build processor and sort of how that flow would look like, and just how quick it can be even using the HP 3D Build Manager. Next, I just want to go over the types of licenses that we have. The way that the licenses can either be bought perpetually, so it's bought once and then it's yours forever. And some modules are annually, so it's basically a leased license. So you'll buy it once, and then you'll use it for a year, and then once the year's up, you'll buy it again, you'll use it for a year. And the way that the licenses actually reside on your computers and how they're used is they're node locked or floating. And the node lock licenses are tied to one computer at a time, and the floating licenses work on a server. So if you host the license on a server and you have 2 floating connections, then 2 people can use the license at a time. If you have 4 floating connections, then 4 people can use the license at a time, etc. But what's great about the floating license is you can have 20 people that has Magics on their computer, and they all can access the license, but just not at the same time, right? So just a quick summary. We talked about the 3-matic software and its latticing and texturing capabilities. We briefly went over the Magic software, about its importing functionalities, its file fixing, structures module, its center module, or 3D nester is what it's commonly referred to, its build processor, and the types of licenses that Magic runs on, or the Materialise software runs on. And now I will send it over to Andy.
All right, thank you so much, Alec, for demonstrating all those powerful features Materialise has to offer. Easy and powerful file fixing is so important in today's world, especially when you have all these different CAD data types. And being able to pack parts and using the nesting tool that you showed is a huge time saver. I can't tell you how many times I myself have used the honeycomb tool in the structures module to reduce the amount of material and agent use on our HP printers. And I know it can also save people a lot of time when it comes to printing on SLS machines as well. Now, obviously, there's a lot of huge benefits to the workflows of powder-based 3D printing technologies, but I also use it across all of our 3D printing solutions as well, including FDM printers. One example here is when printing parts that are too big for our printer's volumes, I will use Magics to split them into smaller parts. And instead of having to go back into the native CAD program and design my lap joint or my connection point, I simply bring it into Magics and then use the wizard within it to specify my offsets for a lap joint, and that's it. Now I have 2 parts, I print them, and after I print them, we'll use some specialty adhesives such as Scotch Weld to bond the parts. The bond is even stronger than the material substrate itself. So by doing that, you can effectively increase your build volume and get more utility out of your printer. So just, one of the many use cases that we have with Materialise. Being able to implement clever solutions like this is an important part of the design for additive manufacturing mindset. And it's something that we specialize in over at Saratech. If you don't mind going to the next slide, thank you. There's lots of different levels of design for additive manufacturing, or DFAM as we call it. Starting off, you can take a part that's designed for traditional manufacturing methods, and it may be perfectly fine to print without a redesign. You just may need to do a simple part evaluation and see if you need to reorient the part and what material you may want to select for that. At other times, you can take an assembly of parts and just simply merge them into a single part to reduce your part count and complexity. That works from time to time. But if you really want to take advantage of 3D printing technologies, you will want to design your part from the ground up, or if you have an existing part, redesign it with DFAM, with additive manufacturing in mind. And at Saratech, we have lots of tools to help engineer parts for additive manufacturing processes. We leverage all sorts of technologies such as generative design and topology optimization, as well as lightweighting and using lattice structures. And Materialise is a very important part of that process for us. We use it quite a bit as well. And at Saratech, we want to help customers adopt additive manufacturing solutions. At its core, Saratech is a product development company, and we want to help our customers make products, better products. And additive manufacturing is just one of the ways we achieve that. It is able to reduce costs and lead times, as well as give you better design freedom, which ultimately leads to better products. Materialise software is an important tool in our toolbox, and that enables customers to have greater success with additive manufacturing. We also have many services that can help you adopt these new technologies. We offer things like prototype development, process development, and training. We do hardware sales, as well as design to print services for our customers. We see additive manufacturing as the next big shift in the manufacturing space, and it's our goal to help customers lead the way with it. We engage with our customers to find the right solution for their business. This entails usually a discovery call or a site visit where we learn from you what you're trying to achieve with additive manufacturing. Next, we look at your current processes to see where there are opportunities for improvements. And then we will review potential solutions and the benefits to your business. Once we implement the solution, we want to continue to work with you to repeat that success so that you can keep using additive manufacturing and make your business better. We're excited to work with you on your next project, so please reach out to us. And I just want to thank you all for your time today.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.